Hi guys. So sorry that I have to go back to doing a few notes, but we do have to catch up on a few of these important properties for trig functions. Hopefully, when you see my face for a few minutes, you can stay on track a little better. So I want to tell you something. I will record the video. I'm going to try to fit it within the 15 minutes, but I will also upload my notes. If this is easier to read, please, after you watch the video, you can go back and actually copy the notes from here. Okay, so this will also be uploaded on your ngrade files for today. You started looking at the graphs of sine and cosine today. We actually focused a lot more on the graph of sine. You will be completing the graphs of cosine activity tomorrow simply by answering the questions on the back of that question worksheet. These here are your parent functions, and you can see some of the important properties of the parent function. I'm going to turn my face off so I can start writing. So over here you see what the parent sine function looks like, and some of its properties are domain, all real numbers. It has a range from -1 to 1, a period of 2 pi. We already saw that with your graphs today. The x-intercepts happen at every repetition of pi. This is what that means, along with 0. The y-intercepts are at 0, 0. It is an odd function. So I want you to pause here and think, what does an odd function mean? Can you see it in the graph? It is the same as origin symmetry. Not just that, but when you have an odd function, I need to remind you that this is the same as f of -x. If you replace your variable with -x, it will end up being the same as -f of x. When you look over at the cosine function, we have a domain of all real numbers again. The range is also between -1 and 1. The x-intercepts tend to start at pi over 2, and then it repeats every pi repetition. So these right here are your x-intercepts. They're always going to be at your halves, or every 90 degrees. The y-intercept is at 1, 0. The cosine function starts at its maximum. The cosine is an even function. So I want you to pause and think, what does that mean? How do you see that in the graph? It is the same thing as saying that it has a y-axis symmetry. Also, an even function means that if you took the function of a negative angle, it is the same as the function of the positive angle. A few more important properties. Since this is your parent function, if you wanted to complete any changes on that function, then you would be adding a's, b's, c's. This is what each one of those means. For the graph of, you can read through that. The important values on here are your amplitude and your period. The amplitude of your new function, I want to tell you an easier way that you can find amplitude. It is always 1/2 of your maximum value minus the minimum value. Essentially, the amplitude is what shows how far away from the midline your graph goes. If you look back at the parent function right here, the midline is the x-axis, and it goes 1 away from the x-axis. 1 above, 1 below. The amplitude also represents a vertical stretch. The period, as you saw today in the activity, shows what is the length of one wavelength and when does it start repeating. So the period is normally 2 pi. If you started at 0, you can go up to 2 pi and then the values start repeating themselves. However, if you have something in front of x, then this will change your period. To find the period of a function, you start with the period of the parent function, 2 pi, and then you divide it by that number in front of x. This number here. We're going to see that with quite a few examples. You can also find the left and right endpoints for your graph using these given equations. I normally don't think to use the equations. Instead, I think what type of horizontal shift has happened on that graph. So let's take a look at an example. First of all, let me tell you, I wish that example 1 was not the hardest example on here. The first thing I want you to do is change the given equation just a little bit. We have y is equal to 4 minus cosine of 3x. I want you to change that 3 into a 2. It will just make it a little bit easier for us to graph. Okay? Clearly, we do not have the parent function, but we can compare this new function with cosine of x. And we can think what sort of transformations happened. Well, it looks like we have added 4. I know we don't see a plus sign, but it is a positive 4, so we have added 4. Because of that 4, we can see that we have a vertical shift up by 4. Really, what that means is that the midline for our graph is now going to be, instead of the y-axis, we have y is equal to 4. Then we have a minus in front of the parent function. That means that we have a reflection over the x-axis. Or in our case, over y equals 4. And then the other difference that we see in here is inside of the function. We have 2 times x instead of just x. This is the same thing as a horizontal shrink, or we're taking that wavelength and the period of 2 pi is going to be shrunk into less than 2 pi. Here, to find our new period, we can use the formula for period, 2 pi divided by b, where b is the number in front of x, directly in front of x. So the period is 2 pi over 2, or just pi. What that tells us is that our function will be repeating every pi on our axis. I think we're ready to start graphing, guys. Our midline is now going to be at 4, and cosine normally, I'm going to just mark off the midline. Our cosine normally starts at a maximum. However, we have a reflection over the x-axis, so this time we will be starting at the minimum. So our cosine is going to start at 3. If the period is equal to pi, based on the look of the parent function, our function goes through its maximum and then comes back to a minimum at the end of that period. So right at pi, I'm going to have that same value. The maximum of a cosine happens right in between, so it will be at pi over 2. Cosine is going to have intercepts right in between of the minimum and the maximum. So I have these points right here. Now I have graphed one full period or one full repetition for the given function. But we do know that this is a periodic function, which means it will repeat itself. So now we can graph quite a few more into that same function. I'm going to graph on the right-hand side. I'm going to repeat a period of pi. Well, if I start at pi, then my next minimum will be at 2 pi. I have a maximum in between, and I have crossings of the midline in between the min and the max, right here. I'm going to attempt to draw a nice curve. I don't know how that's going to go. We want to show that they're not straight lines. It is supposed to be curvy. Not looking too great, but not too bad either. Now, please note that the same sort of repetition can happen on the left-hand side, and I want you to try this. When I'm checking your notes tomorrow, I would like to see that you are showing the same sort of repetition with the negative values as well. Let's go ahead and add just a few more things on here. I want you to note that the domain for this new function is still all real numbers. The range, however, is different. The range is all of your possible y values, and it looks like we go from 3 up to 5. And we already have that the period is pi right above, so I don't need to add that. Okay, let's go ahead and look at another example. For example 2, we are going to graph the function y is equal to 2 times sine of x minus pi over 2. Once again, we are comparing this to the parent function of sine of x. We have a number multiplied in front of x. This is going to cause a vertical stretch, or this is really your amplitude. So we have an amplitude equal to 2. It is the same thing as vertical stretch by 2. We also have a period. You need to know what the period is. Since there isn't anything directly in front of x, the period is going to remain the same as the parent function. It is still 2 pi. But we also have this minus pi over 2 inside of the sign, or inside of the function. That means that we have a shift to the right by pi over 2. Man, that is an ugly pi. Pi over 2. This is what we call a phase shift. Any sort of horizontal shift left to right is called a phase shift. That might be all we need, guys. The midline did not change anywhere. However, we are going to start at pi over 2 because we have that phase shift. The sine function starts at 0, 0 normally. Instead, we're going to start at pi over 2. It has a period of 2 pi. Well, I don't really go out 2 pi away from this pi over 2, but I know that a pi away from pi over 2, I know it goes up, and then at 3 pi over 2, it is going to cross that axis again. Right in between, I will have my maximum. So the maximum will be at pi, and then at 2 pi, it will be at a minimum. It goes back up so that it can cross the axis again and finish this period at 2 pi plus pi over 2. So what is that? 5 pi over 2. Now here, I need to go backwards and repeat the same period. Since I have a midline point here, or a 0 over here, now I can go down to a minimum. Note that the minimum is the amplitude 2 away from the midline. Next, I'm going to go back and cross the x-axis again. I need to go up to a maximum at negative pi. I need to go back down and cross. And then I need to go to a minimum again, and the minimum is at negative 2 pi. Sine is normally not an even function, but doesn't this look very even? Do you see symmetry across the y-axis? Okay, that symmetry happened because of the phase shift. Well, wait a minute. Wouldn't that look just like the cosine function? I want to see if you can come up with an equation for cosine. This has the same domain of all real numbers. The range, though, is different. Range is negative 2 to 2, your close brackets. The period is the same, the midline is the same. I'm going to pause right here. We'll do example 3 in class, and I will upload my notes also. So you are more than welcome to copy everything over. See you guys tomorrow.